There's a number of different ways that we can look at performing dark pixel subtraction in ENVI. I'm just going to go through one of those ways, but I'll talk through a couple of different ways that we can do it. First of all, we can look at our statistics from our at-sensor reflectance image and look at these minimum values, and we can simply subtract the minimum values for each band using band math as we've done previously. We could also identify an area within our satellite image that we believe is a dark target and should be invariable and should essentially have a value of 0 reflectance across all wavelengths, and therefore any value that you see in the reflectance values there would actually be artificially enhanced due to additive path radiance. What we're going to do though is perhaps the simplest method, and this can be used as a default if you know that your data set meets the criteria of being able to use this, and we can do a check on that later. So if we go to Basic Tools, Preprocessing, General Purpose Utilities, and then Dark Subtract, this allows us to simply input our image file. So I'm going to use my at-sensor reflectance image that has been slightly subset to remove those frayed edges that I spoke about previously, and OK. And what I'm going to do here is click the band minimum here, so it's going to subtract the minimum value in each of those bands. I could alternatively select user value and enter a particular value that I wanted for any of those bands, but we'll stick with band minimum, and that's based on the statistics of the image like we've already looked at. Then what we need to do is to enter our output file name. So if you go ahead and run that, what you'll then come up with is your new image. So this is my dark pixel subtracted image, and essentially when you look at it, you shouldn't see visually any difference in your image, although when you have a look at individual pixels and compare them to your pre-corrected image, you should see that there's a value change. So if we have a look here in the left hand display group is the dark pixel corrected image, and if I'm to open in a new viewer here, we'll see that the images should look, to the eye, they should look identical, but if we link our displays and look at the pixel value, you'll see the pixel value is different across those 3 bands that are being displayed, and indeed across the whole image. Now the other thing that we can do is to look at the statistics, and again, so you're just going to Basic Tools, Statistics, and computing the statistics for your dark pixel subtracted image, and I've brought that up here on the left hand side. And if we have a look here at the difference between the 2 plots, we actually see that there's a difference in form in the mean spectral value, for example, and you can see that the actual values in terms of the basic statistics are different. So pre-corrected, we've got a minimum value of greater than 0, and post-correction the value is 0 in band 1, and now the maximum value and the mean value is different as well when you compare that to the pre-corrected image. This is really important when looking particularly at the short wavelengths, as they're the ones that are affected mostly by atmospheric scattering.